Okay, so now we're going to talk about pulling and interrupts. And here I'm going to tell you a little story to help you remember the difference between pulling and interrupt. And the little story is that at my house, we like to have roast chicken sometimes. And given that I travel quite a bit to conference, and my husband also goes to many different events that happen in hotels and such, we are usually tired of eating rubber chicken. So we want the chicken that we prepare at home to be really good chicken. And to prepare a very good chicken that you are roasting, one of the most important things is for you to control the internal temperature of the chicken when you take it out of the oven. If you roast for too long, the chicken becomes dry and is not very good to eat. So typically what will gonna happen is that I'm gonna put the chicken in the oven, and at the same time, I may be sitting at the couch trying to answer some of the Slack questions from the students in Computer 229 or Compute 415. So it's quite likely that I will get very involved in my email, in my Slack questions, or preparing exams or something, and I may forget the chicken. But because I wanted to pay attention, what I'm going to be doing is from time to time, I'm going to be stopping what I'm doing, and I have a very good instant read thermometer that gives me very quickly the temperature inside of the chicken. So from time to time, I'm going to stop my work in my computer, I'm going to go to the kitchen, and I'm going to measure the temperature inside of the chicken. So this is what's known as pulling. The main processor, in this case me working on the computer, has to stop from time to time to go and check to see if an outside process needs attention. So I need to go and check to see if the chicken needs me to take it out of the oven. Well, this is an okay process, but it requires that one, I periodically stop what I'm doing and go check, and many times I'm gonna go check and the chicken is not ready yet, so I wasted my time. I could be doing work. Luckily, I also have a thermometer like this where I can put the probe inside the chicken, and I can set the thermometer on top of the counter somewhere, and I can program the thermometer to alert me when the chicken is at the correct temperature. In this case, I can go work on my computer for as long as I'm able to without having to stop ever to go check the chicken, because when the chicken is ready, I'm gonna get an alarm that will tell me that it's time to remove the chicken from the oven. So in this case, I'm the main processor. I'm not pulling the outside process. I am being interrupted when the outside process needs my attention. So the first case with the red thermometer is the pulling example. The second case with the thermometer that alerts me when I need to do something is the interrupt mode. So that's the interrupt mode. You may be more familiar with an example where you may be working on a programming assignment somewhere, but you are at the same time waiting for a message to arrive in your phone. So one thing that you can do, your phone might be in silent mode, and from time to time, you go and you check your phone to see if the message has arrived. So you stop your main task and you go check your phone. That's pulling. So whenever you're doing that, you're doing pulling. But in another situation, you may say, I will have my phone on vibrate on top of the table. Therefore, I do not need to stop what I'm doing and go check the phone all the time. I can just keep working, and when that important message that I'm waiting for arrives, my phone will vibrate, and that will interrupt what I'm doing, and I'm gonna go check on the message. So that's another example of the same thing. When you are periodically stop and going checking your phone, you're doing pulling. When your phone will vibrate to alert you of the arrival of a message, that's an interrupt on what you are doing. Polling also, another thing to think about with polling is that a processor may have to poll many different things. So it's not just one activity. So it's quite common, for example, in a big building, in the case of the fire, for example, before you can allow people in, you have to check on other rooms to see if they are okay. So you're going to be polling one room at a time to find if it's okay. If everything is fine, then you can call everybody back in. So this is another way to think about polling, that you are constantly going around and checking to see if anybody needs your attention. So polling is like periodically checking the I/O stats register of one or many input-output devices. If the device is ready, you're going to perform the operation. And if there is an error, you're going to take an action. This is common in small or in low performance real-time embedded systems. So, and especially embedded systems, you may want to have very predictable timing for, and example of such system, for example, would be the system that controls the brakes and the engine and everything in your car. Such as an embedded system, you want very predictable timing. You cannot allow too much time to occur between two different polling events, for example. So whenever you need to control the timing, interrupts may not be the best solution, and polling is a better solution. When you want a low hardware cost, you're also going to be using polling. In other systems, polling is going to be wasting CPU time, because the CPU is stop what it's doing to go and check on an I/O device when the I/O device is not ready to be checked yet. In the case of interrupts, the interrupts will, when a device is ready for action or when an error occurs, the controller of that device will going to interrupt the CPU. So unless there is an interruption, the CPU can keep carrying on and doing its job. The interrupt is like an exception. It's processed action the very same way, but it's not synchronized with the instruction execution. An interrupt can happen at any time. The interrupt can invoke a handler in between instructions. So you know the instruction that have finished execution, but it's not like you are in the middle of an instruction like what happened with an exceptions. And usually when there is an interrupt, the cause information will identify which is the device that has caused the interrupt. And for interrupts, you have priorities. The devices that need more urgent attention get higher priority. So, for example, in the case of the power failure that we illustrated before, that will have the highest priority in the system, because when a power failure happens, you have very limited resources to make sure that the system will go down or be turned off in a safe way. So in the case, and that will gonna happen in your laptop too. So your battery is low, and now the computer has to shut down. That shutdown of the computer will gonna take priority over anything else. You can touch the mouse, you can moving from the camera, you can touch the keyboard. Not all that will be ignored because the computer is doing power failure interrupt. And the other thing about priorities is that an interrupt handler that's dealing with a lower priority interrupt can be interrupted by a higher priority interrupt. The last example that I want to talk with you about is called polling watchdog. And again, I'm going to give you an example from my home first, and then an example that might be closer to you if you are not into cooking. But the idea of a polling watchdog. And the story here now is not about roasting chicken. The story here is about preparing a salad. So at my home, we like to eat salads, And we often like to have nuts in our salad, and we like our nuts to be toasted. But the problem is that you cannot toast the nuts too far ahead, otherwise they lose some of their flavor. So often we wanted to toast the nuts right before dinner so that they are freshly out of the oven. I don't want to turn my big oven to toast a little bit of nuts for my salad, so likely I'm gonna use a little oven like this that I have in the kitchen counter. And quite likely I'll be busy preparing some other things, or perhaps looking into the computer while I set my nuts to be the nuts to be toasted in this little oven. And the problem here is that nuts have a very high fat content, so they can go from being perfectly toasted to being burned in no time. And we don't like them to be burned for our salad. So how do we solve this problem? I wanted to be able to focus on my preparation of my meal, or on my email, or whatever is it that I'm doing in my computer, while not losing track of what's happening with the roasting of the nuts for the salad. The solution is to add a timer to my system. So what I'm gonna do now, whenever I put the nuts into the oven, I'm gonna set a timer for 1, 2, 3 minutes, depending on what I'm doing and how my oven works. And this timer will be alerting me that I need to go check the nuts. Doesn't mean that the nuts are ready. It means that I need to go check them. So this is a pulling watchdog, in the sense that what I need to be doing is to check to see if the nuts are ready. But if I don't check for a while, then I'm gonna be interrupted. So that's why it's called pulling watchdog, because the event may arrive and I do not do anything for a while, then I get interrupted. In a pulling watchdog, when there is a cause to interrupt the processor, instead of interrupting the processor, you start a timer and you wait for the processor to pull for the input. So I can keep working while the timer is running. If the timer runs out and the processor has not yet pulled, then the processor will be interrupted. In that case, the alarm will sound. So this was originally proposed for multi-threaded systems. And again, I'm going to bring a different example that might be closer to you. In this example, what I have is that I'm working on my system, and I have all intent of pulling my phone to check for messages from time to time. But now I have a special app in my phone, and that special app allows me to do this. I set the app so that when a message arrives, it does not interrupt me. The message just sits in the phone for a certain period of time. If I do not check for the message during that period of time, so the period of time that I have programmed my phone has elapsed, the message has arrived and I have not checked, then the phone will vibrate to alert me that the message has arrived. So the arrival of the message does not interrupt me right away. It sits there, and if I happen to pull the phone before that time, then the phone will not going to vibrate anymore, because then I have checked the message already. So this is what is known as pulling watchdog.